All right, hello everybody, and welcome. Thank you so much that you could make it to my session, Compose Multiplatform on iOS, stable and production ready. The title on the tin kind of says what it is that we're going to be talking about. Probably the achievement of the Kotlin and Compose Multiplatform teams at JetBrains this year, which is that we are bringing Compose Multiplatform to full production readiness. And actually, it has been production ready for quite a while now. We at JetBrains believe that it is the best way of building multi-platform applications with shared UI, and hopefully, as we will see today, I'll be able to convince you as well that it's a really, really good way of building multi-platform applications. Now, of course, first and foremost, what does it mean that we're stable? Well, it means that we have stable APIs, which is really nice because you get proper deprecation cycles when things change and so on. But there's a lot of other things that go into making a technology stable. And I want to talk to you about all kinds of facets of that. And of course, I also wanted to show to you in action. So today, we're going to get a little bit of an overview of Compose Multiplatform as a technology. We're going to talk a little bit about what came with the stable release. We're also, of course, going to go hands-on with Compose Multiplatform, so we're not just spending time in PowerPoint, we'll also spend some time in IntelliJ IDEA or Android Studio. We'll get a little bit of an overview of what the Compose Multiplatform ecosystem looks like, and hopefully you'll see that a lot of the building blocks that you need to build full-fledged applications, they're already there, and they're already multi-platform, which makes life a lot easier. And of course, this entire thing is also designed to help you get started with Compose Multiplatform yourself. So I'll give you a couple of practical hands-on tips in that area as well. Since it's also in the title, we are going to be mainly focusing on some of the changes and some of the things that we've built specifically for iOS. But of course, when you're talking about multi-platform, a lot of the general concepts that we'll be talking about today and that I'll be introducing, they apply across different platforms as well, right? They are platform independent. Because that's kind of like the key point of why we built Compose Multiplatform in the first place. It's that you, as Android developers, can write code like this, which you very much already know, and you can just deploy it to different platforms. That's exactly what Compose Multiplatform enables. It takes Jetpack Compose APIs and it brings them to different platforms. So, in a way, Compose Multiplatform is the natural conclusion to the Kotlin multi-platform story. So for quite a long time, we already had a stable solution that was validated in practice to share business logic, which was Kotlin multi-platform, or is Kotlin multi-platform. But the part that was kind of missing in this story was, well, not just being able to share business logic, but also bringing the UI layer into this. And now with Compose Multiplatform, you have a really good way of doing that as well and reusing a lot of the knowledge that you already have. The typical case that we see a lot of people doing, of course, are the mobile platforms, iOS and Android, and sharing the UI there. But it's very much worth noting that Compose Multiplatform has additional targets. It has the desktop target, which has been stable for a while. If you've ever used JetBrains Toolbox, for example, to install any of our IDEs, that's an application that's built on top of Compose Multiplatform running on the desktop target. And we also have a web target, which either uses Kotlin.js or Kotlin for WebAssembly, depending on what you want to choose. And that one recently went beta, which is also very exciting, and we'll be progressing with stabilization there. So yeah, the core pitch of this entire story is that we take the APIs that you already know and that we package them for multi-platform. So the Jetpack Compose stuff, where you have already built your knowledge up, we're just giving you more places where you can apply it. And this extends through a whole lot of different bits and pieces that are relevant when you're building modern applications, right? Starts at the basics with stuff like layouts, resource management, but also stuff like state management, right? The way that you do animations, whether they're in a declarative way or whether you're using any of the advanced APIs that are available. Of course, things like material components out of the box, working with things that are more specific to your individual devices, right? Insets, cutouts, if you have some sort of like I keep forgetting what they call like a magic island or whatever the iOS term is for like a cutout in your screen. But of course also more generalized concepts that are still related to UI but aren't exactly visible on the screen, things like navigation, how you architecture things with, for example, view models, or how you work with lifecycle events when an application goes into the background, into the foreground, gets popped off the stack, and so on. I really love giving this talk because typically I don't have to tell you that much about code, right? This is Compose Multiplatform code, and if you've done any Jetpack Compose, nothing about this should surprise you. Composable functions are exactly the same. The way that you handle state, for example, or the way that you handle inputs, it's just exactly the same as if you were just using Jetpack Compose. And this extends all the way to more complex APIs like animations as well. Now, even before we went stable, what was really exciting to us was the quick uptake of the community of this technology. There's a lot of early adopters who were not blocked by not being a stable technology yet, and they really validated this use case, and they showed us that there's tons of cases where being able to share UIs that you had already built for one platform and bringing them to another platform is an immensely powerful thing to be able to do. Now, what I'm particularly excited about is one specific case study, and that's Bilibili. Now, Bilibili, we're here in Europe, so we might not be that familiar with it, but it is one of China's largest video platforms. So they have a couple 100 million users a month, and in their mobile application, they have added Compose Multiplatform. So this is their regular application. And one of the features, so if you like hit that little messaging icon on the top right there, then you'll be sent into their instant messenger feature as part of their like streaming and community platform. And this feature is entirely built in Compose Multiplatform that lives as part of a larger native iOS application. This is rolled out to their user base, and it sees a couple million users actually every day, which is really incredible. Now, of course, the Bilibili app is much larger, but one of the really cool things, and something that makes Compose Multiplatform super unique, is that they could do this type of adoption. Why? Because we allow you to adopt Compose Multiplatform on your own terms. So Compose Multiplatform happily coexists with any of the existing UI that you already have. If you have some Jetpack Compose code in your application, or you have some views on the Android side, you can, of course, use the interop functionality that you already know from Jetpack Compose to work with those. On the iOS side, if you have a Swift UI host that is responsible for navigation in your application, for example, you can have individual screens that are implemented using Compose Multiplatform. And vice versa, you can bring components that come from UIKit, things like video players, maps, camera feeds, date pickers. All of these things you can bring into your Compose Multiplatform applications as well. And then they will just live as part of your app. This is really, really exciting. One of the other parts that's also very nice is that since we're kind of asking you to move from Jetpack Compose to Compose Multiplatform when you're building things, it's not that we're introducing some sort of like interoperability layer when you're building your Android application. Literally during the build step when you're building the Android part of your app, the artifacts get switched out for the literal Jetpack Compose artifacts. So there's never a scenario where adding Compose Multiplatform is going to add any kind of performance degradations to the Android side of your application, which is really cool because it really lowers the risk of trying and adopting Compose Multiplatform in your projects. But yeah, this kind of incremental adoption story that we hear popping up more and more, whether that's Bilibili, whether that's Sony, whether that's a couple of cool banking or eID providers, it's something that's really, really nice, and it allows us to now really confidently state that Compose Multiplatform helps power the experience of millions of users. So we were talking about stable. That's kind of like the whole thing of why we're here, right? And one of the parts that I already mentioned was that, well, Compose Multiplatform as a stable technology, provides you with stable APIs, so proper deprecation cycle for things, and strict compatibility guarantees. So you don't have to worry about breaking changes or having to rewrite your application like after each release. So this is one of the commitments. But there's another commitment which is maybe a little bit less tangible, but I think it's equally, if not more important. And that's that we want you to be able to build shared UIs that feel great on all platforms. And that feel part is actually something that's really, really important. Because that's kind of what makes or breaks when you're building multi-platform applications, right? If the application does not have the feeling of something that is native, not necessarily the look, but the feeling, then it feels quite alienating to a user, and it might not be what you want to actually put out there. Putting this into words is kind of hard, so I'm just going to show you what I mean. If I had a slightly bigger budget, I would of course tell you, you find a brand new iPhone under your seat right now, and you can just like do it yourself. Unfortunately, that's not quite in the budget, so we're just going to take a look at it in the emulator, and hopefully that's still going to get the point across. So one of the classic applications with which I like to demonstrate this, simply because it's our own application, is the KotlinConf app. KotlinConf call for papers is currently open. If you want to submit a talk, please do. So here's the application. It's running on an iOS emulator right here, iOS simulator. And it is built entirely using Compose Multiplatform. So every single pixel you see here, that comes out of a Compose Multiplatform application. When you use it, like on the very first step, you will see that, for example, the scrolling has the exact same kind of like springiness that you would expect from an iOS application. This is already something that's like very natural. I can switch over here to this other tab. I can do like a little bit of like, for example, the overscroll. And if my multi-cursor does not betray me, we can see that we kind of get this springiness here, which really makes it feel a lot more natural and really like iOS, well, native. It goes a little further as well. If I hop on over here and I go into my search field and I type something, I can, for example, select some text, or if I have some text selections that I drag, it pops up the native magnifying glass that's based on the actual iOS implementation. So this isn't a recreation. This is actually the iOS text selection at work, which also means that you get all the native, for example, context menu clues here as well. Now, another part that's particularly interesting, I think, is always navigation. So in iOS, one of the very classic patterns is kind of having this like stack with like kind of a parallax effect. And again, you kind of get this out of the box when you're using Compose Multiplatform. So you have this kind of page that sticks to your finger as you swipe back and forth. The page behind it like swipes left and right as well. And this is all behavior that you get out of the box just by having like regular navigation implementations. The scroll effects are all things that are out of the box if you have like lazy lists, for example, that are scrollable. So we're really just trying to provide you with all of the like little details that make an application feel good physically when you handle it like with your fingers. But we really want to kind of go all the way with this. Like we want to provide you with all the same integrations that a regular native application would have as well. One of the examples that I really like showing off here for that is, for example, clipboards. So, for example, here I have a small application. I have 3 little icons, and on each of these icons, I've attached like a clipboard item. So I can grab this here, for example, this little apple, and I can pull it down here into like a drop zone, and well, associated with the apple was the words Compose Multiplatform for iOS. With the little robot, it's Android. And of course, over here, it's desktop. And again, this isn't like a recreation of the implementation. What I can do is I can grab myself an element here from my Compose Multiplatform application, and I can head out and, for example, go into Safari and drop this into the search bar, and then the text Compose Multiplatform for iOS gets searched, or I can drag it into my notes, or I can have contact information and I can throw that back and forth. That's super useful, and it just really, I think, hopefully shows you that what's so important to us is that you can provide the entire consistent experience that feels good for your users. Now, of course, another part that always coincides with feeling is also not doing things like dropping frames or being kind of choppy. And that challenge has gotten a little bit more difficult with the introduction of high refresh rate displays as well, with the 120 hertz displays. So we're very excited that for all of our cases, we're hitting those benchmark targets of 60 FPS and 120 FPS, even in more complex, for example, scrolling tests, which is really nice. We're not stopping there. We're pushing it a little bit further even here. If you're already doing some experiments with Compose Multiplatform, here's something you can try. It's called parallel rendering mode, where instead of doing a whole bunch of things on the main thread, the actual rendering can be offloaded to a dedicated separate thread, which means that the layouting phase, the measuring phase can happen on one thread while the rendering happens on another thread. And again, that's a chance for us to give you even more speed ups. This is a flag that you can simply add by setting in a view controller parallel rendering equals true. This is experimental, so it might not be perfect. We are relying on your feedback here. It's also really important that your applications feel good for all of your users. And that's why we've spent a lot of work making sure that the accessibility support is really, really great in Compose Multiplatform when you're deploying on iOS as well. Again, on Android, of course, since it just decomposes, no pun intended, to Jetpack Compose, that's where you already have all of the things that you're used to. On iOS, you get integrations out of the box for things like VoiceOver, right, that reads out text. You have assistive touch and full keyboard access so that people who are using external input devices can also still navigate through the tree of elements in your application as well. The text inputs, that they're also all accessible, so if you have alternative input methods, you can also use those. And we've made it possible for you to specify custom traversal semantics. So if you have an application that has a lot of complex layouts where a screen reader, for example, might not necessarily want to traverse everything from like top left to bottom right, you can specify in which order elements are supposed to be traversed. All of these things are exposed as regular APIs for you, and they mimic the Android APIs as well. So you have the full capability of making sure that your apps feel great for everybody. So that's kind of the idea that I wanted to express when I said we want you to be able to build those great feeling applications. We've been talking a lot about users. Let's talk about you for a second as well, because developer experience is, of course, also one of the parts that's always relevant. Let's talk about tooling for a little bit, because newsflash, Compose Multiplatform is built by JetBrains, and we at JetBrains are a tooling company. So we really love building tooling and making developers more productive in all kinds of ways. And to do that for the Compose Multiplatform case specifically, we have published a plugin called Kotlin Multiplatform. You can find that plugin in the plugin store for both Android Studio and for IntelliJ IDEA in any kind of the recent versions. Seeing is believing with this story as well. So I'm just going to hop into IntelliJ IDEA here, and we'll just take a look and see what kind of fun things we have available. So hopping out of PowerPoint and hopping into IntelliJ here. First, let's start very easy. I don't even want to take a look at this code just yet. How do we actually start a new project? Well, we have in IDE wizard, so when you hit File, New Project, you can go to the Kotlin Multiplatform section. A little limited on screen space here, but you can see that I can pick a couple of different targets that I want to have. So for example, Android, iOS, and I might also add desktop. And you can decide whether you want to go the Kotlin multi-platform route, so sharing business logic, or the Compose multi-platform route, which is sharing UI as well. And we have the same also for example, the web target. I've already done this so that we save a little bit of time on the Gradle import, and I've already opened up this project. The first thing that you hopefully will not notice, but that will spring into action when something goes wrong, are our pre-flight checks. Those are living down here and over on the side here. And these will actually happen in the background as you open a project. We have a little tool that essentially scans your development environment and makes sure that you're on the right operating system, because when you're developing for iOS and you want to run, you unfortunately have to be on a Mac, that you have the right Java versions, that your Android SDK is set up correctly, that you have an Xcode version that is compatible specifically with the Kotlin compiler version, and that makes sure that your Gradle projects can actually be imported. Luckily, today everything already has a green check mark, so we don't need to do anything here. If there was a problem, like for example, if I had an outdated simulator runtime, there would be like a little exclamation mark, and there would be a quick fix that you could hit, and it would automatically run the appropriate command to make sure that you get the right outcome. Okay, very good. From there, you can kind of like start trying to navigate around in your multi-platform application. Here we can see that we have 3 targets. We have the Android target, we have the iOS target. Sorry, we have 2 targets. We have the Android target and the iOS target. And then we also have a source set which is called common main. That's where all of our platform independent code lives. And we can see here that the code that I have open here is actually a platform independent implementation of like a tiny little application here. If you're a seasoned developer, you can probably quite simply spot what was going on in this code. But if you're a more visual person like me, you can also pop into the overview. That's not up to date. Give me a second here. There we go. And we can get a little bit of an overview of the actual application. Of course, we can also do things like we can jump into the animation preview where we can see the keyframes on our animated visibility. I can kind of like scroll back and forth, and you can see here that we got kind of like a Compose logo popping out at the bottom. So previews are supported even when your code is written in a platform-independent manner. Of course, from there, like actually running the application on an iOS device, like here where I have an iOS app set up with the iPhone simulator, is also just a matter of a couple of seconds, and then we get the actual application also running. Okay, very nice. Only having a button, maybe a little bit boring, so let's write something that's maybe a tiny bit more interesting. Let's get rid of all of this code, and instead we're going to write a little like Codies application. So I'm just going to say val Codies, and then I'm going to remember from my Codies service the Codies that are available to me. And we'll render these in a lazy vertical grid. This seems vaguely correct. Let's make sure that we actually also then render the individual elements. So we have our items. We might put them, for example, on a card. All right, AI Assistant is really like zooming through this kind of stuff for me here, which is nice. So I'm just hitting a couple of tabs, and then we can still take a look at the actual code. So we just have a card with a couple of paddings and elevation. And then we are rendering the drawable resource, which is associated with each Codie. It gets a small content description, and here we're cropping it to a square. So we might rerun this application. And just like that, we have a couple of Codies. Very nice, very elegant. And of course, you can see once again that without me having to specify like or override any of the behavior, we get this like springy, if I can let go of the mouse correctly, we get this kind of springy behavior. We get like the overscroll effect that kind of bounces back in the same way that an iOS user would typically have. And I didn't have to do anything out of that. We just get it out of the box. What's probably also worth talking about a little bit here is the actual drawing of the resources that we have. So if I actually jump in here, we can see that our Codie service just gives us a list of drawable elements. So this, again, it should look quite similar to you, but instead of the R object, which you use to access Android resources, we have the res object, which instead resolves to compose resources that are stored in a platform-independent manner. So here you can see all of them. I can, for example, command-click on the happy Codie, and it will pull it up here. This generally supports all the formats that you also have on Android. On iOS, because we own the rendering engine, it even supports SVG, which is quite exciting. Unfortunately, if you run that same application on Android, it won't work. That's not an us problem, that's a Google problem. If you want to have SVG native support, then please talk to the wonderful people who are doing the Android office hours. Very good. Okay. Hope I didn't forget anything here. We've seen that there are wizards that allow you to get started really, really quickly. We have pre-flight checks that make sure that your development environment is actually set up correctly, and otherwise we guide you to a place where everything works well. We have previews that allow you to even interactively take a look at, for example, things like animations. We could run our application. Thankfully, I didn't make any kind of mistakes, so the debugging part was spared for us this time, but we also have native debugging that allows you to pause and set breakpoints in iOS code, for example, as well. And we've seen that we have resource integrations as well. But there's another really, really cool thing in the kind of Compose multi-platform ecosystem, and if you've caught my colleague Martin's talk earlier today, then you kind of have already been spoiled on what's been going on there, and that's hot reload, the ability to quickly make changes to your code without having to restart your application. Again, seems like one of those things where slides would not do it justice, so instead, let's actually hop into our IDE once more. But this time I'm jumping into the Kotlin Conf app, but I'm going to run it on the desktop target. So Compose Compose Hot Reload is currently available for the desktop target because we do something quite fancy with the underlying JDK to like switch out classes and so on. Let's actually just take a look at it in action. So I'm just running the application here for a second. Very good, we can see it here. And thanks to the zoom level, it's maybe not that easy to spot, but you can see that there's like a little widget that kind of like follows around wherever I drag the window. And that's our Compose Hot Reload, like little diagnostic window that just kind of is associated with our window here. So now I can make a couple of changes. So for example, I can hop over here into the speakers. I don't know, I'll also type in maybe some text. And we can probably notice quite quickly that the spacing between these items doesn't look particularly good. So instead, for example, I don't know, we'll add like a padding of like 15 dp. And after saving, the Compose Hot Reload machinery kind of starts up. The first reload typically takes a little bit longer, but then you can see that immediately the changes are applied to our running application. State is preserved entirely, including the highlighting and the search that we had here. So all of that is fixed. And now that it's already warmed up, I can make changes even more quickly. So I can, for example, change it to 30. I don't know, I could change it to 12. Maybe the round corner shape, I actually just want to have like something that's like a vaguely round corner. So we can kind of change the clipping of the actual background. All of these things are quite simple. But of course, you're not really limited to just the like very minor changes. What you can also do is instead of, for example, having this implementation for the speaker screen in its entirety, I might also, I believe this is a speaker grid, I might change this to a speaker carousel. And then reloading this page, or reloading our code, we can see that now we've just exchanged like the entire implementation for the screen, and it still works well. And you know, you can add an arbitrary number of different components, and your application just reloads and it keeps working. So if you want to have like a couple of codies raining down, that's something that also works really well. Now, here's also Compose Hot Reload pairs very well with one of the other great technologies that we're building at JetBrains, which is, for example, Junie, our agentic AI. So I can like pop into this here for a second, and I can just type something like on the speaker overview page, use a 2-column grid instead of a list, then change each speaker card to have the image above, the text below it all, and all centered. Something like this. And then we can run this, and effectively now what's really nice is that since the Compose Hot Reload allows us to see changes quite quickly, right? As changes are being made, for example, by our agent across the the different places, then we will also see the updates of our application pretty much in real time. If you've not seen Juni work before, you can see that it kind of like starts exploring the code base in pretty much the same way that you most likely would as a developer. So it kind of takes a look at what might be relevant and then makes the changes at the place that it deems the most relevant. We'll give this a couple more seconds here. Otherwise, we will simply return to this in just a little bit. We've seen a change. Hot reload has made the change, so we can see now that we've got the grid layout, which is a really cool way of making like quick changes or just quickly validating. If you have an idea, this might look nicer in a different way, you can kind of fire off ideas quite simply against an agent, and you can kind of vibe yourself to something that you as a developer think looks better. We'll revisit this in probably a minute or two. Never mind, we're already done. Very good. So now we've got the speaker cards with everything centered, kind of like what we had actually designed. Very nice. Close this application because it has a habit of staying on top of Windows. Yes. So, in conclusion, with hot reload, you really get a faster way of prototyping your applications. Right? You can change your app's UI. You can even do this on the logic layer as well, because it's all it's all Kotlin code, right? And you can see the changes without ever restarting. We're currently having this on the desktop JVM target specifically, which is maybe a little bit of a limitation, but there's a good reason for it. It runs on top of a customized OpenJDK build that we at JetBrains have been maintaining for a couple of years now, probably over a decade at this point, because it's the JetBrains runtime, which is also the JDK that runs Android Studio and IntelliJ IDEA, like the thing that actually makes sure that your IDE works well. And it uses something very fancy called DCEVM. If you're more interested in learning more about this, come talk to me after the talk. We're always happy to geek out on this stuff. Now, I probably hear you saying, okay, well, I'm a mobile developer. My application does not have a desktop target, so I don't really see how this is relevant to me. I would posit that this is still relevant to you in a whole bunch of different cases. Why? Because if you have, for example, if you're building your application in a way where your design system is kind of decoupled from the rest of your application, right? If you have a module dedicated to your UI widgets specifically, then you can simply take those UI widgets and you can kind of wrap them in a gallery application. So the gallery application doesn't need to have platform-independent implementations of all of your UI logic. It simply can just be a container for all of the different UI widgets that you have that you're often prototyping on. Again, maybe this is something that we can just very briefly show off here. So actually, if we take a look at the Kotlin Conf app, we will see that there's a UI components Gradle module where all the things like buttons and so on live, and then we have a UI components gallery, which allows me to just run only the gallery. I hope I have... Here we go. To only have the gallery application that just has the different types of elements. So we can see this here. And of course, this is like a completely interactive gallery, right? Because it just runs the individual components. And I think you can quite easily understand how if I'm like making iterations or changes to the platform independent part of my elements, right? Like if I'm changing the strings or the radii and all these kind of things, how that would be quite beneficial to do quick iterations, even when I'm not deploying my entire application to the desktop target. So this is just something that's maybe also quite neat. If you want to learn more about Compose Hot Reload, it's an open source GitHub repository. Please check it out. And as we've seen, one of the really, really exciting things is that since we're not inventing new APIs, but we're bringing APIs that have been established and have been out there and have been written about and have been coded with for a long, long time by now, Compose Multiplatform works really, really splendidly with like all the modern AI solutions as well. So if you have a question of like, how do I build this layout? Well, your typical ChatGPT or the Claude can answer you those questions in a multi-platform use case as well. So these are kind of two important points that I would still add to the tooling sector, both hot reload and AI integrations. Now, of course, just building an application is a little bit more than only building the actual UI. There's a whole bunch of other things like platform capabilities, navigation, image loading, architecture components that's also required if you really want to build a multi-platform use case end-to-end, right? And one of the parts that's particularly important for us to have an easy access to is platform APIs. So those bits, right? Because the platforms typically provide you some sort of unique implementations for a lot of common use cases, whether that's a maps provider, whether it's a video provider, and so on. Let's actually take a brief look and see what that would look like in our implementation. We hop back into our small app demo. And what I would like to do now is I would like to add a video player to our application here. So I already have a small setup here because the good part is the entire machinery that we've already developed for Kotlin multi-platform of expect actual functions where you specify kind of a common interface and then provide platform-specific implementations, that also just works using Compose. So here you can see I'm just saying I expect my platform to implement a video player. And I can hop in here on the Android target. This is an EXO player-based implementation. It's not particularly interesting, but it does use this Android view, which is kind of like the interop layer, right, to bring this into our application. More interesting is what that might look like on iOS. So I am going to hop on over here, and again, I'm just going to write this up real quick. So just like you have an Android view controller, like an Android view interop, we have the same thing for iOS. And in iOS, you just can create a UIKit view controller using a function. It takes a factory first and foremost, and here we just create everything that we need. So for example, we create an AV player. I believe I can just create an NS URL directly like this from our string. Then I also need a controller that's associated with it. The wonderful thing is that all of these things are parts of the official documentation. So if you're looking up how to do this, you can quite literally look it up in the the UIKit documentation, like in the official Apple documentation. This actually just takes the name parameter string. So now this should be all good. The only other part that I need to do is also make sure that I pass in the modifier. And this is the entire implementation of bringing a video player into your iOS application. Again, there's no, I didn't prepare some secret code or anything. This is the entirety of the implementation. Let's briefly see it in action. In our multi-platform application, I'm going to put the entire thing into a column. Make sure that that actually is fit max size. And then we'll just drop in a video player. The URL is not the Rickroll, but that's a good one. We'll just say the get video URL. And AI Assistant really already wants it to be 16:9 aspect ratio as well. So we'll let it do that. And running this application, we now have a video player up here with native controls. I can click it, and if the conference Wi-Fi works, there we go. We got a little dancing Cody using a native video player. So again, there's very little code that I actually had to write here, and all of a sudden it unlocks me the full abilities of the platform, which is really, really exciting. All right, yeah. So we've seen this, and again, I didn't really do anything special here. You can pick out what an AV player layer is or what an AV player is just by looking at the official Apple developer documentation. We just expose the entire thing, the entire iOS SDK as part of your Kotlin code. So you don't need to write any kind of wrappers or anything like that. You just write Kotlin code. You obviously don't want to do these adapters all the time yourself, so you can use community projects like CAF, Compose Adaptive Look and Feel, that provide you things like date pickers and so on. Okay, very briefly, since we're running out of time here, I also just want to talk about architecture components. The good thing is that we've pretty much brought all the important architecture components to multi-platform. So if you need view models, well, good luck. Or good news, I should say. Also good luck, perhaps. But yeah, so like the view model APIs are exactly the same as they are on Android. So if you need a view model scope to launch something, you get it out of the box. If you want to do navigation, this is currently a navigation 2 example, but like everything from deep linking to type-safe navigation, adaptive navigation, that all simply works. And we're bringing navigation 3 very, very soon into the Compose Multiplatform universe as well. Around this, you also find a super productive ecosystem. For example, for loading images, the classic go-to library on the Android world, Coil, is also already a multi-platform library, so you can use it in Compose Multiplatform natively as well. If you're doing dependency injection, Coin, the people that you can also talk to downstairs, have wonderful support for Compose Multiplatform specifically, if you want to inject things like view models. And if you're a Dagger fan, well, since a couple of months, the Dagger folks have also been working to support KMP, which is super exciting. There's a lot of persistence libraries that you can use out of the box, but I think the most interesting one for seasoned Android developers is Room, the official persistence library from Google, which has also been supported as Kotlin multi-platform. And this is part of Google's kind of overarching support for Kotlin multi-platform for sharing business logic, which we're really, really excited about. It's a pretty long list, actually, of what libraries there are. Navigation 3 will be coming very soon in Compose Multiplatform 1.10.0, and that will also include all the lifecycle stuff. So yeah, with Compose Multiplatform, you get 3 targets that are already stable, where you can do all of these kind of things that I just showed you, and you get 1 target that's already in beta and that's rapidly approaching stability as well. So yeah, you get shared UIs that feel great using the established APIs adoptable on your own terms, with full access to your platform capabilities and a rich ecosystem that also provides you with solid tooling. I hope that you will start building something when we're done here, which should be very, very shortly. You know where the wizard is, which is right in your IDE, and you can go to jb.gg/compose to find all kinds of interesting information, and you can find wonderful people in the Kotlin Lang Slack. If you haven't joined there, there's a Compose dedicated channel. Thank you so much. I'll be like roaming around downstairs, and of course, like I'll be here if you just want to catch me. So if you have any questions, any comments, please let me know. Otherwise, we also still have a roundtable from JetBrains. So if you have any questions, come join us tomorrow for that. Thank you very much for your attention. I appreciate it.